All right, so today we're going to take a look at this little guy here reacting with hydrochloric acid, very strong acid, used for some very interesting reactions in the workplace. So the first thing we're going to take a look at is which double bond to break down to connect to this into the anti-bonding orbital to separate this strong acid. Well, the first rule to remember in this situation is that never destroy the BB. Now, what's the BB, you ask? It's a little term I invented, very nifty. It stands for the benzene bagel because you have this benzene that I drew right here. You see that the orbitals actually resemble somewhat of a bagel. Obviously, this one is the opposite phase orbital to this one. So this level of hyperconjugation basically gives us a really low energy, relaxed form. So what we're actually going to take a look at is this bond right here. Now, this bond, we can see this pair of electrons is actually going to attack the anti-bonding orbital on the hydrochloric acid. So now what this does, this captures an H onto here. So now our job has to be to determine which carbon gets the charge. So we look here and we see this carbon is a 1, 2, 3 tertiary carbon, right? And this carbon here is a 1, 2, 3 tertiary carbon as well. So we think, oh, should I make the carbocation like this? Or like this? Decisions. We organic chemists have to make very important decisions. However, if you look at this one, this itty bitty little positive charge is sitting all by its lonesome. Versus if we look at this one, this positive charge is feeling very good right next to this benzene ring because of the delocalized electrons. Now if we look here, we can shift these around all day and nothing is going to happen that's significant. However, if we decide to shift this here and this here, you see we're able to create more resonance forms, which makes this a lower energy diagram. So obviously in this case, as you might have noticed, we see an H right here. Now on an exam you might not draw this, however this is just to clarify for you. Versus on this one, we see the H being added here. So we know that this is good, or this is good, and this is bad. Low energy, high energy, very bad stuff. So then we look at the final product and we see, oh, almost forgot, silly me. There is a Cl minus right here, the chlorine from the HCl. So we see this pair of electrons and we essentially plug it into wherever we can. Now remember, don't disrupt the benzene bagel. So you take this pair of electrons right here and you basically plug it right in to the positive charge. And you end up with, and I'm tired of drawing the damn benzenes, this. Once again, I will draw the H just to give you some peace of mind. And we see this positive charge, itty bitty positive charge right here. And we draw the curve arrow of the electrons fitting right into this comfy, cushy little spot right here. So as a result, we get our little boy chlorine right there. Now that's the final product and the preferred product. Have a nice day, organic chemistry students.